All right, so today we're going to go over TDD and BDD, but the basics of which. We're just going to be going over unit testing. So these are really important concepts, especially if you're going to be working at a company like Pivotal or any large-scale company which works in a test-driven behavior or a behavior-driven environment. So let me just pull this up real quick. And I'm going to start doing screen share. So let me share my screen. Hello, Kent.
Hello.
I've always been a model.
Hey, Master. What's up, man?
Okay. Oh, this is PHP if anyone's interested. And that's done with PHP. Can you guys all see my screen? Hello? Can you guys see my screen?
Yes, yeah.
Cool. All right.
No.
No?
Yeah.
Okay, cool. What?
I will silently interrupt your guys' stuff. But look.
That's pretty great, actually. Oh, yeah, I need to pull this lecture up on my phone. Excellent. Okay. So today, you guys are going to recognize when unit tests are appropriate. We're going to be using two technologies in tandem with one another, Mocha for the testing framework and Chai for the assertions. You're going to be able to describe a feature in terms of unit tests, and you're going to develop and submit a Oh yeah, the project proposal is already going to be done. You guys have done that ahead of time. All right, so right now, how have you guys been making sure your code is working as expected?
We're looking at dog video.
No, not you guys, the UCLA group.
I tend to just write a bit of code, get something working, and just test it as I go along.
Yeah, that's what I do. I do like console.logs, and then maybe I'll put some stuff into an HTML to see if it renders.
Right.
Stuff like that.
Okay, so console.log statements, checking the front end, maybe even going as far as getting logs being outputted, right?
Yeah.
Checking server logs as well for backend, front end logs for front end. All right, so this is pretty time consuming and error prone to test code. So taking the time to call functions, reload pages with different configurations can take up to a minute at a time. And it's difficult to ensure that to execute the same click sequences, the same settings in different configurations, like checking behavior in Firefox versus Chrome. So if you guys did like cross-browser comparisons of like the same behavior, would be super tedious, right? And you guys haven't really done much of cross-browser comparisons, but you know there are ways of like testing that using technologies that are available on the web. But that also gets to be pretty tedious as well. And manual testing is useful in certain cases, but it doesn't really scale, right? Like you can have someone like go through a series of steps and test everything step by step, but it's really time consuming and error prone because humans are humans. So we're going to set up tests automatically that check the validity of our programs. And this eliminates certain problems of scalability. So testing can feel like unnatural at first, but once you guys get used to it, then it'll make like complete sense. And I think you'll guys start you guys will start getting into the behavior of doing test-driven development and behavior-driven development. Because essentially the way we're going to set it up, it's going to be more like, hey, I'm going to do testing and talking about testing, and based on these different parameters that I set, I will create my code. So it's essentially a kind of pseudocoding. And I'm going to show you guys what that means in a bit. So why don't we get to practical examples? All right, so, oh, I haven't pushed up today's stuff, huh? Let me push that up real quick. Okay, you guys should have everything on UCLA now. So this part, I'm just going to go through, and just like everything else, I'm going to go through with you guys, so it wouldn't matter either way. The files are there mostly for you guys to just follow along. So for error handling, we're first going to have this example of just something very basic. So we have this JavaScript file, and we start off with useStrict. And with Node, we have, okay, var file name, we get the argument, which is just going to be a file name. A mock error is going to come from our helpers.js file. So we actually throw this error, and we're actually using this read file function. It doesn't actually do anything. All it does is actually throw an error. One thing about the throw error, it requires the error itself that's being thrown to be contained within a function. So I can't just put throw inside of here. It actually needs to be in its own function, then I need to call that function. So
is this just straight JavaScript right now?
This is just straight JavaScript. There's nothing else. There's no Express. There's just Node, basic Node, no server, nothing like that. Just file system stuff.
Okay.
So what's happening over here is we're exporting this mock error, and we're exporting this read file. So these are both functions, right, that we're exporting. So we have these over here that are being imported, right? So we're requiring these, and again, these are just coming from here. So we get the mock error, which is a function, the read file, which is a function, and when I call read file, then what's going to happen is no matter what I pass in, it's going to throw an error. It's going to say error file system appears corrupted or file does not exist. Try again later. So go here. And I do node try catch example.js, and it's just going to give us this over here, throw error. And this is an example of what normally would happen, and what they want to do is, if you don't have error handling, this is normally what occurs. You actually have these errors being thrown just like this. You're just going to see some kind of weird error. It's probably going to have the line number, but it's not going to show like really what error happened. And it's going to stop the system. So it stops your application and prevents anything from happening. Now, on a production server, you can imagine this being very disadvantageous to a user and to you as an application developer in general, right? Because if you have something that is going to destroy the system just based on any kind of error, that's not good. And you know, it's going to destroy user experience, and you're going to lose customers. So you don't want that to happen. So right now, all it's doing is emulating a normal error that would occur if there's no error handling to take care of it, right? So it stops the system, nothing else runs, and it just throws this error. So a better way of handling it would be to do something like this. So we have fixed.js. And this one, it says error reading undefined. Error logged, continuing. The rest of your program worked. So the error is logged, and as long as it's not essentially like a functional component of the rest of your application, and it's separated, then the rest of your application should work just fine. And the error should be logged and should be sent to your system. So this helps us catch bugs not only earlier on, but it helps us gracefully degrade. And graceful degradation is really important because we don't want our application to just fail and throw a bunch of errors and the user's like, what the hell is going on? This is a piece of crap. Is it hacking my system? I don't know what's happening. You want something that's like, oh, okay, something happened. It told me the rest of my application is now working in general. There might be some functionality that's not working, but you know, this part is just not working, and that's fine. So if we look at the fixed, what actually happened is we have this try catch block. Now, those of you who have worked with statically typed languages or done more computer science stuff, this might look familiar. So what's happening here is you're saying, hey, try running this. Try doing this read file with the file name. If that doesn't work, catch this error. Notice that before we didn't have this try catch. We're just like, hey, do it. And we know what's going to happen, right? It throws an error. We're screwed. And the whole program shuts down. So instead, what this does is it catches that error. It says, oh, error reading the file name. Error logged, continuing. And it says, hey, the rest of your program worked. Cool, right? So this will not shut down your system. So this will try and read, as the keyword says, the file from the system, but it'll move on if there's an issue. Again, if it's a completely functional part of your application, this could cause some issues, which is why testing is important before you deploy, of course. But if there is something on runtime, then the catch will help with that. All right.
So Omar, real quick, the catch logs it in the log file, so that way we can catch it later on.
Yeah, it logs where it happened. So this will be the error. So the error that was thrown gets sent to here as opposed to the system. Instead of like just sending this, it'll actually just log it.
Okay.
Like normally you would actually send it not to the console to an actual log file, right?
Yeah, exactly. Yeah, so you would send this to a log file, like to server logs or something. If the error occurs on the front end, then you'd send it to like, you know, you're logging on the front end. If it's on the server side, and logging on the back end.
Is that pretty similar to like Redux?
Yeah. So in terms of like, you know, testing frameworks, well, this is going to be something that we're going to be working with in any programming language. The try catch blocks, these exist across all programming languages. So you know, anytime you try and do like a try catch, I can't think of a language that doesn't have like a try catch block. So it's analogous to like almost any language you use that's object oriented. It's like C++, Java, Python, things like that. So whatever you work with, it's going to have a try catch block. All right, so
Omar, are you saying block, like B-L-O-C-K, try to catch block?
yeah. So this is like a single block of statements. So you use them together, like an if-else block, right?
Yeah.
So when I say block, I refer to like these.
Okay.
Yeah.
Cool, thanks.
All right. So now, yeah, I'll go over that. Okay. So when we write tests, we'll often need to check that a function throws an error. So we're going to do some function testing. So this is going to be like unit testing. We're going to check to make sure that functions work. So they want you to do all this, but I'm just going to do for you because I think it's kind of complicated. And we just, I don't know, doesn't make sense. All right. So they wanted you to create a function called assert throws, which takes an argument called func. Like not with a K, but func standing for function. So this is going to be like a callback function, right? Oh, there's a mistake here. Can anyone show me what the mistake is? You can tell by the syntax highlighting. Huh?
Oh, no.
Right here. See? All right. So what it is again, if you guys have like a what is it called? A single quotation or a double quotation anywhere throughout your code, that's going to throw off a lot of stuff, right? It's going to assume that everything's a string. So syntax highlighting always helps with that kind of stuff. All right. So we're going to have this function called assert throws. It's going to take in a function. So we're going to pass this function in. When you pass this function in, does it automatically get executed? No, exactly. So we're passing it in by as an argument, right? You can pass functions around.
Right?
Yeah, exactly. So you can pass by reference. You don't actually have to pass the function as an executable. It doesn't have to execute immediately just because you're passing in. You can pass it in just like anything else. So we're passing in this function. From there, let's see. This function that's going to be called is actually referring to this function that we created over here. So we have a very simple if-else statement. This if-else statement is stating, hey, if x or y are not a type of number, so type of just means, hey, the data type of the variable or the parameter in this case is not a number, which means that, hey, if it's anything but a number data type, like if it was a string passed in, if it was a boolean, if it was an object being passed in, then it would say, hey, either x or y is not a number, please try again with numbers. Otherwise, just return the product of these two numbers. Makes sense, right? Anyone confused on this part?
No, but actually, the func isn't the func on line 8. Isn't this where it's being executed?
Yeah, so this is where it's being executed, correct.
Right.
Yeah. So we got so far on what multiply is. It checks for x and y, makes sure that they are actually numbers being passed in. If they're not, then it just returns the product of those two numbers, right? So what we're going to do is we pass in this multiply. So when we call assert throws, we call it with multiply being passed in, and we state what the two numbers are going to be. So if we state what those two numbers are going to be, then these two numbers over here are going to represent those. We start off with through is going to be declared as false. So it's instantiated as being false to begin with. And this is going to determine if a function was thrown or not. Now, again, remember when I said that you can't just call a throw by on its own? You actually have to wrap it in a function. So this is why we're going to need something like this. All right, so we're going to try, and we're going to catch. So we're going to try and execute func with x and y. And if this works, then it's just going to return x and y. However, this catch actually looks for this throw. Okay? Sorry, this throw right here. So if there's a throw, then it'll go to this error. This throw refers to an error happening. This is basically just error catching. So it's the same thing as we did over here, right? Where, oh, okay, well, we have error handling. So instead, now we're actually doing it with a real function. We're saying, hey, we're testing this function. Does it work? If this function works, cool. This works, and we can just go to function through as expected. However, if there was an error, then through is going to be equal to true. And then what we're going to do is we're going to say, hey, if it's not equal to through, so through equals false, which means that this one was, let's see, not through, wait, is this correct? Hold on, let me check the logic here. If not through, function did not throw, not through, yeah, that's correct. Okay. Okay, I'll see you guys later. Bye. See you guys. Okay.
What do I do with the blanket?
Just leave the blank here. Okay. See you guys.
Bye, Lightning. Kyler, you brought us an owl.
Don't forget to bring it down. I can't even say it. Don't forget to bring it down. How do you make that high-pitched voice? Sorry, my other students are leaving right now, so I'm just saying bye to them. I can't do Tally's voice. I'm really sad.
Who?
Tally.
This is like high pitched.
My throat's too fucked right now.
Ask Mikey. He probably knows how to do it.
Okay, see you guys. Bye.
We'll see you in a bit.
Oh yeah, I'll see you guys in a bit. Alright, no problem. Okay, so not logic always confuses me. So this is the same thing as this. Because this implies not throw means not true. So through is equal to false. So we start off with the default false, and this default only changes if there's an error thrown. So the default, if this works, should be not through. That's confusing, right? But does anyone have questions about that?
I do. Okay, so where you have the variable through,
Yeah.
that's anything, like that could have been, as you would say, that could be like booger butt or something. But where you use the word throw below, that's
Yes.
part of the try catch. Like that's part of the how this thing works.
Correct, correct. Yeah, so this is just a variable I made up. Through and throw are completely different. These are just, so this is just a variable. Booger butts. There.
Okay.
So now we have booger butt is equal to false. If not booger butt, and now it's completely different than throw, because throw has nothing to do with through. They're just semantically linked together, right? Not functionally.
Okay.
So good question. So again, what's happening is if everything goes well, this stays false, whatever this is, just for us to use. And so if it's still false, function did not throw an error. And then if it did throw an error, then it would say, okay, function threw an error as expected. This is a very cynical approach. It's not as expected. I mean, come on. Okay, so this is a very basic kind of way of testing, and it's kind of convoluted. So we have better ways of doing this. So we're going to go into testing now.
So hold on a second, just to recap real quick. So
Yeah.
what we're doing here, we would call assert throws, and we would actually pass in multiply to it. Is that correct?
Right, so let's go to it. Let's use assert throws. Let me see if this would actually work.
And so when you pass in multiply into assert throws, you do try. If it catches an error, then, or if it throws an error, it'll say throw the error that's in the multiply function, correct?
Yeah, so let's try running it. Let's see if it works. It might not work because nothing ever works, and I always have to fix things. Okay, so it looks like it works though, so should be okay. Assert JS. Can I call it like this, and then I send an argument? Oh, this doesn't even let me send an argument in. So I'd have to use something like this. And then what I can do is, oh, this is just a front-end JavaScript file though. I can just use this on the front end. But then I have to attach it. Okay, so here. Codepen.io. So anytime I want to like test like front end stuff, I'll just use something like this. It's a lot easier than me putting the file, like attaching it to an HTML file and all that crap. Let me see. Do I need anything? Do I need packages? This is all front. Yeah, this can all be front end stuff. It doesn't require anything from Node. And I can execute this using assert throws. I can just call in multiply. The arguments are going to be, I don't know, 4, 8. I'm going to change the default behavior. And let's check the console. And function did not throw an error.
Okay, so what we're saying here is we say, just hold right there for a second. So with multiply, we're saying if if all of this is false, then we are throwing an error, which is throw being a keyword or a what do you call it?
Yeah, it is a keyword. It's a yeah.
Yeah, so we're saying, okay, actually throw this error, and then we're passing. So we're passing multiply into assert throws, and we're saying, okay, if there's an error, throw this. So we're catching the error in assert throws, right?
Yeah.
Okay. All right.
Yeah, this is why I didn't want to do this yesterday. This is like pretty complicated stuff.
No, I just needed to make sure I have the logic right.
No, but it is complicated, right? Like it's not something I can just quickly go over. And I think this would have thrown you off from your projects as well. So, and it's important too. So if I run this again, and what I did was I added a console.log of what x and y would be. Because if I just return this, it doesn't do anything with it after. All it's doing is like, okay, try this. And it's not, well, actually, I can just do it here. And that would be more efficient rather than doing it twice. So there you go. So it shows that it didn't work, or that it did work. And now if I do this, 3 and banana, or even something that's a string being passed in, function threw an error as expected. So it worked, right? We actually threw an error. So we passed in what? Normally we'd have type conversion, right? But type conversion didn't go through. Why is that? Sorry, do you guys remember what type conversion means? Or coercion?
Yeah.
Yeah, like
implicit conversion.
Exactly. So you're implicitly, like normally you'd implicitly convert, number. Actually, in the case of yeah, actually, would it work with multiplication? I forgot. I can test it out real quick. 3 times 4. Yeah, it would implicitly convert. But in this case, what's happening is it doesn't, because we first have this if statement that checks for data type, and then it will throw this error. So ignore this completely. So then it'll go to this, and this will set this off, and it will just ignore everything else. But because we have,
if you put one string format and one integer format?
It should still do the same thing. So if we did this, it should still throw the error.
Right, because the y is checking for the y is strictly doing a strict check.
Yeah, so this is checking both data sets. Sorry, both arguments being passed in.
Well, but the x is only being loosely checked. The y is being strictly checked.
Oh, you're right. There we go. I didn't notice that. Good call. Nice.
I wrote that piece.
Hmm?
Can you hear me?
Hey, Eric, you're back to life.
You can hear me?
Yeah.
Yep.
And I wrote that before because I didn't think people could hear me.
Oh, okay, thank you. I appreciate that. Again, there's probably going to be more bugs in the system. So the reason I think that one actually worked was, yeah, so this is actually triple equals, and this is double. This would be double equals. One just checks data type, and one checks. One checks value, and the other one checks data type and value. All right. So let's move on to the next part. I'm supposed to give you guys a break, but I'm not going to give you guys a break. All right, so now we're going to be working with Mocha. So to install Mocha and Chai, these are actually testing frameworks on your local machine. What you do is, I already installed these, so I'm not going to do it again, but you do, go into this, you type in npm i-g, then you type in Mocha. You'd probably have to do sudo before if you're trying to install anything globally. And then you'd have to do npm install -g for Chai. Again, that's our assertion library. And if you wanted to just install locally and not globally for Chai, you guys can do npm i-d and then Chai. But I think you guys are definitely going to be using this a lot, so I suggest just using it globally and then just using it whenever you need it. Okay, so now let's get to our examples for Mocha and Chai. All right. So let me just open this up. All right, so for our testing framework, this is actually written in behavior-driven development fashion. So let's say that we have a function that we wanted to work. So instead of the way that we had it before with the try-catch, we actually have a testing framework that takes care of this for us in a much cleaner way. So we have multiply equals function y, if type, blah, 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 all the exact same thing. Oh, look, they actually did it right with the 2 equals signs this time. Let me make sure there's no errors here. If, yeah, I think it's fine. Okay. So they actually have the same function for multiply in here. We good so far on that? This is the same function that we just went over. Yeah, okay, so this should that we're using over here is actually just using the function should from Chai. So we're using the npm module called Chai, and we're gathering the should function, and we're just saving in a variable called should. And that just makes it easier for us to call it later on. So I do this a lot too, where if you're trying to use something over and over, and it's like giant, like require something, 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 then just save it into a variable, and then it becomes a lot easier to like pass around, and you have less code. So we have this should, and what we have over here is the structure of a Mocha test suite. So in here, what we're gonna do is something that's important as a concept. So I want you guys to really pay attention. This actually is when you develop applications, like let's say at Pivotal, they're very big into this, and what they'll do is they'll set up the tests first for the functions that they're about to create before they actually create the functions. So essentially, it's just pseudocode, if you think about it. It's pseudocode, but it's also validating the pseudocode. So it's saying, what should the behavior of the function be? And what does the user want? So you say, describe let's say multiply. What is multiply supposed to do? And it's not just like, it can be just the function itself, or it can be a concept. And it says, okay, so you have describe, and this is just a string that's just for you. This can be booger butt. You can be whatever in here. This is just for you to understand what you're trying to describe. And then you have this callback function. So this is saying, okay, it should multiply properly when passed numbers. Again, this is just for you. The computer doesn't give a shit about what that string is, right? It's going to look at that and be like, whatever. This is for us. And there's a callback function. So then you call this function that you created over here, and you pass it different values. You say 2 and 4, and because Mocha and Chai are written in such a cool way, you can actually say should. So this is actually assertions. Assertions are basically you're doing the testing. Mocha is the test framework. And sorry, I've been talking all day for the last like 8 hours. And the should is an assertion from Chai. And equal is also part of Chai. So this allows us to say, hey, multiplying 2 times 4, so whatever the result of this is, get the result of that. And with should, what it does is it allows you to then take this value and then pass it to another assertion. It says equal, and then you just pass it a value, and it says 8. So how you set this up is actually very much like how you'd set up something in English. So everything looks really clean, and it makes sense. So you set up this test first, and you set up what it's supposed to do, and you make them fail in the beginning. So you're going to set up all the different use cases you can think of. You'd start off, of course, with like basic use cases, and then you can think of things like edge cases that would be like, okay, if every 1 out of like 10,000 users does this one thing, then it should do this. And it should throw when not passed numbers. So before we actually do anything, we actually want this to fail. So right now, there's 2 different assumptions we're making, right? We're saying, hey, it should multiply properly when passed numbers. So actually, let's create an empty function that does nothing. And it should throw when not passed numbers. So again, we're doing this iffy because throws require the throw to be within a function itself. So whenever we're using this throw error, just have this iffy like this. Okay, that's just like the way throws work. So don't read too much into it because you're gonna get stuck on it a little bit. You can take a look at the documentation if you want to know, why throws require that and all that, but it's really not that important. So what we do is we do the exact same thing. We're just executing the function. This is gonna throw. This should throw an error. The error is then encapsulated in this function. This function is then executed, and then that is gonna say, oh, it threw an error. Okay, so did this throw an error? This is a check. Throw and then error, and then that should equal to true. So if this all works, then when we run node test, oh, it's not in ls test. Oh, did I install? I thought I installed Chai. Oh, no, I didn't. Okay, npm install. Package.json. Let's check the package.json. Dependencies, Chai, yeah, okay. Thought I installed Mocha. Describe is not defined. That's because Chai is not working. Oh, good. And it exited out. Oh, stupid. Okay. Let me see. Did I miss something? npm install Mocha chai. Yes. Yes. Describe. Right. So why doesn't describe work? Let me see if everything works right. Oh, let me check package.json npm test. No, it's just default testing. Test, yes. What? Oh, stupid Mocha. There we go. God damn it. Oh, okay, sorry. I forgot about the syntax. It's Mocha. All right, so I forgot that the Node application is not supposed to be running the tests. Node has its own testing built in, and that's what npm test does. And I was trying to run that as opposed to what we installed, which was Mocha. So to run Mocha, you just actually type in Mocha, and then you can actually just pass in a directory with all the tests inside of it, and it'll run all of those tests in a row from top to bottom. Sorry about that. Okay, so if we did Mocha, and then we just hit test, and that's a directory, and all of it passes. However, if I take this out, Mocha test, look at that. So I get 2 failing tests, but it's actually really cool the way it looks, right? It tells you, how long the test took, and where it fails, and what exactly happened too. So it's really cool. And the way you do behavior-driven development is you actually start off with failing tests, and then you create your function such that it will start passing. So let's start off with the first one. So 2 times 4 should equal 8. So that should work. Let me see. There you go. So we have 1 test passing. So it says should multiply properly when passing numbers. Cool. And now I want to say should throw when not passing numbers. Okay. So now I'm going to refactor. I'm going to add some functionality. And boom, we should have the ability to make all of that work. Run Mocha test. And now we have all the tests passing. Pretty cool, right? Right. I'm shaking my fist, but you can't see me.
Totes.
Okay.
Yes, you are right.
Thank you. Okay, so there's more than like 1 person here. Good. Wow, so cool.
Always right.
Thank you. That's all I expect is just absolute compliance. Okay. Any questions so far? Nine?
Oh, so one question I do have, this would apply to any language, is sorry if this is not an RPod question, but so when do you actually test? So for example, you could in theory test for every single input and go overboard and all that other stuff. What are the typical parameters or guidelines for? I mean, I can understand like reading files and such because there's all kinds of things that can go wrong. But something as simple as this, like for example, you could simply say, oh, if it's not a number, then just kick it back to the user and say, hey, give me a number instead, that sort of thing.
Yeah.
So where's kind of the line of actually throwing an error versus just actually handling the error?
So it depends on like how you want to build a function, how robust you want it to be. I would suggest actually making a minimal viable product where you have most use cases taken care of, and edge cases. I mean, you can have a very robust system with like 1,000 tests for this like one multiply function, but what's gonna happen like the majority of the time. You actually just want it such that you have what the user wants, which is something that's functional and like 99.9% of the time. And when you have like, some small complaint of like, some users been like, well, I typed in this script and then like, I ran this script and it executed and I had to inject the system and then, it ran and it didn't correctly, use the multiplier. You're like, I don't give a shit. I would just be like, I don't give a shit. But like, I mean, if you really do want to build something that's like, like fairly robust, like Facebook or something like that, then you are going to test for a lot of cases. And you're going to have like, errors that are very indicative of exactly what happened. When you have like, especially if you have like millions of users where, edge cases become, even 1% of millions of users is a lot of people, right? So
really what you would have is a multi-layered approach. You would say the basic things like, hey, I expected a number, you gave me a letter, try again.
Yeah.
But then for everything else, you would say, hey, I don't know what to do with this, or basically I chose not to specifically handle it, so just throw the error and log it.
Yeah, exactly. I'll just say like, hey, we're not sure what happened, but and Reddit really has a lot of those of like, well, they used to. I think now they're better about like giving specific indications, but they'll just be like, we don't know what happened, and it's kind of funny and it's kind of cute sometimes. It's like, oh, okay, well, at least they're being honest about it.
Right.
So
yeah, that makes sense.
Yeah. So yeah, testing you should and behavior-driven development is actually really cool because you start thinking like the user, and it allows you to be more fluid. So as opposed to like exactly what the shelf is supposed to look like, it's more like how does a user want the shelf to behave and look like and in general. So if you change the way the shelf look, the functions should still pass as long as the shelf behaves the same way. So it's a way of actually creating very like fluid tests that get into like granularity, but also allow you to like not break tests every time you rewrite the function. So that gets more into like like the theories of like how behavior-driven development works and against TDD. But essentially, you guys should be always thinking about like what does the user story actually want? What does the person who assigned me this task actually want me to do? Do they want me to like fix every single problem? Do they want modularity? Like, what is the end goal of this? Like, the user wants this kind of behavior. So in general, it should fulfill these kinds of things. And I think that's what we should always be doing. And that's like the lean startup approach too, with like the agile methodologies is like focusing on the client, what the client wants, not just creating something like based off your own thoughts and things like that. It's really just like an iterative cycle of like what they want, implementing that, and then like just pushing it to production with everything working. Cool. And then constant iteration, of course, based on that. I highly suggest actually reading Eric Ries's Lean Startup. I think I read that like 4 years ago or something. I don't remember like the details, but the concepts are all pretty cool. All right. So any other questions, or can I move on?
Keep going.
All right. Okay, where am I going? Okay, doing something. Let's look through what they want me to cover. Oh, so you guys were supposed to get familiarized with the Mocha and Chai documentation. Choose to read either the should, expect, or assert guide and refer to it throughout the exercise. So if you guys actually go to Chai.js, they have should, expect, and assert. Should and expect are part of behavior-driven development. Assert is more of TDD. So I suggest. Did I send you guys a video of TDD versus BDD and OPP? Yeah, you know me.
I don't think so.
Okay, I'll send you guys that. That's actually really important. It's actually what Pivotal was talking about yesterday. They discussed that a lot, and it's actually pretty important as a concept, especially at time. I think around Los Angeles, a lot of companies are doing that. So I'll send that video out if someone reminds me. But essentially, you can use one of three approaches for assertions. One is the direct assert, which is just like, hey, do this. Is this assertion type of, so is this function a string? Is this function this? So, does this function result in 3? Does this, or length of, sorry, foo is 3. Is the property flavors length of this? Whereas a behavior-driven approach is more like, well, I'm expecting this to be this, or it should be this. So it's written more in the way that a user would write it, right? So you have it more of like, okay, I'm expecting it to be like this. I want it to be more like this. So it is just semantics in a way. There are differences somewhat functionally where I think should actually changes the object.prototype. So if you don't want that or you don't have access to that, then don't use that. Otherwise, you can just switch between them or use whichever ones you wish to use. So should and expect is what we're using in ours, so we're going to stick to that. So if we say, foo, which is we're going to assume that foo is a function, or in this case, returns a string. So we're going to say foo should be a string. In this case, it returns a string called bar. So foo should equal bar. And then foo should have length of 3. So these are all different tests that you can actually use inside Chai. And then these are the assertions that you can use as well. So it reads like English, and it's actually really cool, easy to use. And there's some really cool documentation, shows you how to get started and all that stuff. But I'm just going to do it with you guys so no one gets confused and has panic attacks. So yeah, they wanted you guys to create this function. You guys can actually create this function, but it'll just take a long time. So we're going to be lazy. All right, so we already did this example. And we're just going to do disembowel instead of disembowel. They're trying to be cute. And this is using
ES6.
Yeah, so this is some ES6 going on. This is a function delimiter. This is a constant instead of var. So just think of this as being function. So what am I missing? What did I do wrong? That'd be it, yeah. So that would be the same thing. But we're just going to use ES6 in this one. So what this is referring to is this is a function that's being called. It's being stored in a constant called disembowel. And
This
we're
is
just
an iffy, right?
Yeah, this is being stored in a this isn't iffy. Yeah, but it's being stored inside of a variable. Yeah. So this would be actually, yeah, I think it would make more sense for me to just here. Did I miss anything? So
Because normally you wouldn't wrap a function in parentheses, right?
right, yeah, I think that's what I was missing. This is an iffy. Okay.
Right.
So let me do this. Should. Yeah, okay. Okay, so I think this should help unconfuse some people. In case you guys aren't familiar with ESX now, this is the same thing. So we have a function that's first going to check to see if a string passed in is not a string but a type of number, and if it is, then what it does is it stringifies it and just returns that string. So let's see. Blah, 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 blah. Formula size, blah, blah, blah. What did they want you to do? Consider function. Oh, okay. So it's actually a very basic function. All it's doing is it's saying, hey, accept a string and return a version of the string without vowels. So basically, this would be the string, this would be the function that would return that. So if you passed in a string or whatever you passed in, if it was a number, then what it would do is there's no vowels in there anyway, so just stringify it and return it because there's no vowels. Otherwise, I don't know why they decided to go with regex because we haven't really gone into regex. Use regular expressions. And what this does, it says, hey, replace any instances in this entire string that has A, E, I, or U with nothing. So just remove them entirely and then return that. So that's going to be stored inside disembowel. Cool. So this, whenever this is called, this immediately gets invoked, and the return value is automatically stored in disembowel. So that way, when we actually call disembowel, this is storing. Let's see. Yeah, this is storing the actual value of disembowel. So when we say these tests over here, we say describe disembowel. Again, this is just going to be a string for you. It doesn't matter what you really put in there, but it would make sense to name it based on what you're supposed to be doing or which function you're calling. From there, you set up different tests. So at this point, we actually want to do some critical thinking. So if you did want to, so before we actually create this disembowel, what you're supposed to do is create tests that would fail, but that you want to test against this function. So you say, hey, it should remove all vowels from lowercase strings. Cool. So if you ran disembowel, this is lowercase, it should equal this is lux. Okay, so the I, the O, the A, and the E are removed. So if I actually shit. I thought I was right. Oh no, that's fine. Okay. Yeah, that's right. So if I try to run this right now with all these different tests, and I'm going to go through them in a bit, I should first start off with failing tests. So go to solutions, go to Mocha, and run test. Good, all of them fail. So we have 5 different tests, all of them failed, and it said, hey, oh wait, type error. Oh, that's a different failure. npm install chai. I have to install everything in here? Install, come on. Okay. It should give me back property. Let me see what happens if the pass. All right, that is working, right? but I don't think it was reading the assertions correctly. Let's see. Oh, yeah, we're not running any errors. Yeah, that's why. So notice that we're not returning any kind of throw. So that's why we're not getting a proper like return of like, oh, well, this is what's going wrong. All right, so what's happening is what I'm going to do is remove this stuff again. And I'm going to do this one at a time. So it says it should remove all vowels from lowercase strings. All right, it should remove all vowels from uppercase strings.
One more.
Yeah.
Just a second. So I didn't realize this before. I just noticed that on rows 3 and 4, or lines 3 and 4, there's a comma before disembowel.
Yeah.
I thought that was just a typo error, that was supposed to be a semicolon, but that's actually the syntax, right?
Yeah.
It's actually the structure.
Well, I mean, like, this is the same thing as, yeah, so this is the same thing as this.
Oh, gotcha, okay. Gotcha.
Yeah, sorry, if anyone's confused about that, yeah, it's the exact same thing.
Okay.
So if you're doing multiple variable declarations, then you just do that.
Gotcha.
Sorry to confuse you guys if you guys are confused about that. Okay, so we have should remove all vowels from uppercase strings. So then we check for uppercase. So this is uppercase, should equal, this is, right? So this should do this. Should remove all vowels from mixed strings. So no matter what, it should remove everything. Should ignore numbers in input strings. So if this has numbers in it, doesn't matter. It should still, keep those numbers in there and just remove the vowels. And it should cast numbers to strings. So the easiest one to work with is actually this last one. So what I'm going to do is build this last one first. So I'm going to say if type of string equals number, just return that string. So I'm going to try and make this one work first. Easiest for me. And look at that. First one, or this last one works now. Should cast numbers to string. And what we did is we said, okay, call disembowel, pass it a number, should equal this string. Cool, right? From there, this entire regex takes care of all the other tests. So this takes care of lowercase, uppercase. Doesn't matter. It's just like, okay, anything in there, replace it. So we run test, boom. So this removes all vowels from lowercase strings, from uppercase strings, from mixed strings, and ignores numbers in input strings. So when you run this regex function, so regex is actually really important. It's really powerful. I suggest taking a quick look at the basic regular expressions. I wouldn't worry about it right now, but maybe after you guys finish your last project, then start looking into regular expressions. I doubt they're going to ask you about it during interviews, but it can come in handy when you guys are working with stuff, especially for search and replace type stuff.
Yeah, most of the basics is just copy paste from stuff you can find on Stack Exchange or whatever.
Yeah, there's a lot of stuff out there that, it's like all the basic stuff, like I'll probably remember, and then like anything advanced, I'll just look it up. And there's plenty of like regex generators out there too. Like if you want to do something, I'm like, oh, okay, this is how you do in regex. So it's pretty cool. So we just actually ran some tests and we passed some tests. We had some tests fail. And then we supposedly, quote unquote, wrote our test to make it pass. So now this is actual behavior-driven development. And this is what a lot of companies like Pivotal, and this is how they work. Now, you're probably wondering, well, why the fuck did we start doing this now if this is how we're supposed to start off with? And that's because, we had to start off with functionality before we get into testing, because you wouldn't know how to test if you didn't know how to do functionality. So it's kind of like catch-22. So there's always a way to retrofit testing onto an existing application. And that makes sense, right? If you want to add testing to an application, you can always add a test afterwards. You can't do behavior-driven development because you've already created the application, but you can add tests to it. So if you guys wanted to add tests to your applications for project 2, you guys can do so. It's definitely not required. But if you wanted to, go ahead. And I'll be sending all this information to you guys as well, like all these modules and everything. Any questions so far? Okay.
So you have to, so we're, in this particular case, for example, we're requiring Chai, but we also have to install Mocha. Is Chai relying on Mocha? Is that what you're
Chai
saying?
does rely on, well, Mocha uses Chai
Okay.
for assertions. The assertions are like should, expect, assert,
Right.
and those are all part of Chai.
So why do we have to install Mocha as well?
Yeah, so and Mocha is like the framework around it.
Ah, okay.
Yeah. So this part's like Chai, this part's like Mocha. These are all the assertions. Like actually executing like stuff is the assertions. Like this part, actually just this part right here. This is all Chai. And this is just for unit testing.
Okay.
Okay. So you guys are supposed to work together. We're not going to do that. Titleize. Okay, so here's the next one called titleize. So what you guys are supposed to do is write tests for a function that title cases incoming names. For example, if you have titleize something like this. So if I did this function, not titleZine. Hannah, is this even a correct conjugation? Does titleize exist as a word? No, thank you. Mr. Jones. So if I ran that, that should return Mr. Jones. So any kind of title should be given capitalization for the first letter, and then given appropriate marking like afterwards. So a period should come after like the R or the S for like Mrs. and things like that. So we're gonna test for that now. So let's open up our fancy application. And why don't we take a look at our tests first? So our tests say, okay, we're gonna get the should from Chai. We're not using expect, we're not using assert, so we're just getting the should. We're gonna require a file that we are storing our function in, or where we will be storing our function. So why don't we make everything fail. And over here, we're going to say, okay, describe titleize. And again, this is just for us. This part's just for us. It should capitalize initial letter of each word in input. So Seth Godin should become Seth, is it Godin? Godin? I don't know. Godin. So the output of this titleize, the return value should equal this capitalized first name and last name. The next test should append period to leading titles. So I should have titleize. I take Dr. Zhivago, and that should equal doctor. So the capitalization of each one of these. So for the title and for the last name are capitalized, and a period is given after the title. It should not change properly case strings. So Mr. Alexander Pushkin, it should not change anything in there, so it should be exactly the same. Excellent. It should add periods to properly capitalize titles, so this should have a period at the end of the MR, and should probably mix case strings. So if I have Mr. and I have Alexander, so this is like someone on Twitter or like fucking, I don't know, Yahoo Answers is typing some shit in, and you're just checking all of it, and you're like, okay, wait, stop doing that. And it's gonna clean it up and make it look like this. So in order for these tests to pass, we're gonna have to create a function that does all of that crap. So this is our function. There's a lot in here. So notice, yeah.
Sorry, I guess I'm slow. But so in a test-driven environment, you would actually write what you have on the screen now first, correct?
Yeah.
And then you fill in your function to make every one of those pass.
Yep.
Okay, all right, that makes sense.
Yeah. So you're essentially saying like, hey, this is what it's gonna have. So essentially, if you think about it, it's just pseudocode, right?
Yeah, right. And all it's doing is it's just checking the return value against whatever you're supposed to equal, right?
Right. Yeah. So right now we're just doing, okay, this function is supposed to, and that's just for unit testing, right? Unit testing is just like checking functionality of like functions, not how the whole application works, not how components of the application work, but just these individual functions.
Right.
Okay, and they're likely going to look something like this, like large functions that take in things and do a lot of stuff. Like so if I were to uncomment all of this.
But in a perfect world, if all of the functions work independently, then when you put them together, the whole thing should work.
Yes.
I mean, that's the whole idea behind it, right?
Right, and the thing is, with functional testing, which we're going to get into tomorrow, then you're going to see, oh, okay, well, we're going to use some other application, some other module that's going to allow us to test for how these different modules work together, because the individual units might work, but how they work together and what they return as a functional unit might not work.
So then, at the end of testing, you just throw these tests away. Is that typically what happens?
Yeah. So you're just running these tests, and that's it. You don't need to use them anymore. You don't need to push them up. They can just be like ignored.
So it's not included as part of your package. It's just a throwaway file.
Yeah. Correct. So that's why it's like installed globally, and I generally would save it to like dev, in case someone else did get it. So I do like --save--dev, instead of like installing it as part of like the package.json. So if someone wanted to run the test, they could just npm install, run it. But like when it goes to production, it's like you don't really need it. And then you should have a testing server. So this should not just be on a local server. It should be on a production server. And with unit tests, you can also, there's a lot of cool things that you can do where you can actually do like API testing, things like that, where you're actually testing the HTTP requests and what's getting sent back and everything. So there's some really cool things that you can do with it. So you can test like everything from beginning to end. And again, this is not just like back end, this is like front end testing as well. Like all of this you can run on the front end. So you can test for like, if your jQuery is working right, your jQuery functions are working right, your JavaScript functions are working right, and everything like that. Okay. So again, same thing. All you do is just, comment out. I mean, in real life, you guys aren't going to be commenting out. You guys are actually going to be building things. But if I commented all this stuff out, then you'd see like, okay, well, I'm passing this test, now I'm passing this test, now I'm passing this test. And eventually you end up with like, something that fulfills all of your end goals. And you have tests to go along with it. So this creates some really cool, clean code that performs well, and it matches what the behavior of the user wanted at the end. So you start thinking a little bit differently. I mean, you should be thinking about this anyway, of like what the user wants. But sometimes, you know, you just sit down and you're like, oh, I don't want to like, you know, write things out and everything, and I don't really care. I'll just write tests later. This forces you to write the test first, and therefore, like, you know, at the end, you don't have to go back and try and write tests that will more than likely fail. And, you know, having to refactor code and go through all of that headache. So it saves a lot of time at the end, and it reduces your technical debt significantly. With that, I think that's it. If I run this solutions, yep, all of them pass. Cool. Any questions? All right. Well, if that's it, then I guess I will see you guys tomorrow.
Thank you, Omar.
No problem. All right.
Yeah, appreciate it.
No worries. All right. So this is recorded. I'm gonna upload it to YouTube. Takes a while. Actually, I'm gonna first have to convert it using Handbrake, so it's smaller, and then upload it to YouTube. So it'll probably be up tomorrow. Cool.
Cool.
All right. See you guys tomorrow then. Peace.
Peace.